Hello, this is Mrs. Scarpel, and this video is all about graphing absolute value functions. So an absolute value function is a function that contains an absolute value expression, much like the equations and inequalities that you've done previous to this lesson. So when we are graphing an absolute value function, we base it off of the parent function f of x equals the absolute value of x, which we have pictured here on the right side of the screen. The graph is V-shaped and symmetric, so much like a parabola is. Its vertex is located at the point 0, 0. Much like the vertex of the parent function of y equals x squared is. Now you'll notice that the slope on each side is a rise of 1 and then either moving to the right or to the left 1, depending on which side of the function you're looking at. So if we think about why this is the case, well, if I have the absolute value of 1, it's going to equal 1. If I have the absolute value of negative 1, it's going to also equal 1. If I have the absolute value of 2, it's 2. The absolute value of negative 2 is also 2. And absolute value of 3 is 3. The absolute value of negative 3 is also 3. So if I look at those points, when x is 1, its absolute value is 1. When x is 2, its absolute value is 2. When x is 3, its absolute value is 3. When we go to the left side, when x is negative 1, the absolute value is 1. When x is negative 2, the absolute value is 2. And when x is negative 3, the absolute value is 3. So we get this nice V shape. The domain of an absolute value function is all real numbers. Because as we can see on this graph, we have arrowheads on the end, so this is just going to keep continuing in both directions. The range, however, remember the range is the y values. And this doesn't have any values below the y value of 0. So from 0 up, we have values on our graph. So we can say that the range is y greater than or equal to 0. And this is for the parent function. If we were to shift this graph up or down, it would affect our range. And we're going to see that here in a little bit. So graphing each function, compare each graph to the graph of f of x equals absolute value of x, describe the domain and range, and identify the vertex. So when I'm talking about transformations of absolute value graphs, they work much like they did for the parabolas that we had when we had f of x equals x squared. Here we see that we have the absolute value of x plus 2. This plus 2 tells me that it's going to shift up 2 units. So instead of having a vertex at 0, 0, our vertex is going to move up 2 units. So the location is 0, 2. I don't have any value in front of my absolute value to tell me if there's any stretch or shrink, so there isn't any. And so from my vertex, I'm going to go up 1, right 1, up 1, right 1. Along the right side, on the left side, it'll be up 1, left 1, up 1, left 1. And then we can graph our function by going through the points. So the domain, as we can see, is going to continue on the left, it's going to continue on the right. So the domain is all real numbers. But the range is everything above a y value of 2 or equal to 2. So the range is y greater than or equal to 2. If we take a look at example B, this time we have the plus 3 inside the absolute value. Well, just like when it was inside the expression being squared, this means we're going to shift left 3 units. Remember, when it's inside the grouping symbol, it's going to be opposite of what you think, because it's -3 that would cause this to equal 0. So that means my vertex will be shifted to the left 3. So instead of being 0, 0, it's -3, 0. And we can make that nice, perfect V with slopes of 1 and -1 on each side of the vertex. And this is our graph. Again, the domain is all real numbers. It continues to the left and to the right. And its range, remember range is y values, so our lowest y value is 0, and everything above, so y is greater than or equal to 0. On this function, h of x equals absolute value of x minus 1. That minus 1 is outside, so we're going to shift down 1 unit. That moves the vertex from 0, 0, down 1 unit to 0, -1. We don't have any stretch or shrink, so we're going to have this up 1, right 1, or up 1, left 1 on either side to create that V shape. So the domain is all real numbers. And the range actually goes down to -1, so it's going to be y greater than or equal to -1. For example B, we have the -4 inside, so it's going to move opposite of what you might initially think and move right or shift right 4 units. That moves the vertex to the point 4, 0. We make that V by going up 1, right 1, up 1, left 1. The domain is all real numbers. And the range is y greater than or equal to the lowest y value is 0. Now we're going to write the function represented by each graph. So we can see here on example 1 that it shifted left 6 units. So when we write the equation, and it says write the function f of x, so we're going to write f of x equals, open up the absolute value, x, since it's a -6, we want a +6 inside the absolute value, because when it happens inside the absolute value, that's how we get the horizontal movement. For number 2, the vertex moved down 8 units. In that case, f of x equals the absolute value of x, but we do the minus 8 outside of the absolute value because the vertical change appears outside. So here's some more. Number 1 moves 5 to the right. When it's a horizontal shift like that, the change appears inside, and this time we're using h of x, appears inside the absolute value. And right is a positive direction, so inside the absolute value we want a minus 5. And number 2 moves up 3 units. So this will have h of x equals the absolute value of x. The vertical change appears outside as plus 3. So in summary, a graph of a function in the form g of x equals x plus k is a vertical translation of the parent function f of x equals absolute value of x. A graph of a function in the form g of x equals absolute value of x minus h is a horizontal translation of the parent function f of x equals absolute value of x. And the domain of any absolute function is all real numbers. Now we're going to take a look at some that have both a horizontal and a vertical change. So remember, what happens inside is going to be horizontal, what happens outside is going to be vertical, and those values give us our vertex. So in this first graph, we see that our vertex is located at 4, -2. That means it went to the right 4 and it went down 2. So the equation will be, let's just call it g of x to separate it from the parent function. So g of x equals the absolute value of x minus 4. We subtract the x value of the vertex minus 2. The plus k, in this case, because k is negative, we can write a minus 2. And that is the equation. Now, if I'm describing the translations, I would just need to say right 4, down 2. Let's take a look at another. So if I describe my transformations, I'm always starting from 0, 0. This graph went left 4 and up 2, giving us a vertex of -4, +2. You wouldn't have to write the positive sign like I did. And the equation would be g of x equals absolute value of x plus 4. We would be doing essentially a minus negative, which becomes plus. So x plus 4, and then that vertical translation is a plus 2 on the outside. Here we're given the equation, and we need to describe the transformation and graph it. So if we have the absolute value of x minus 3, that's going to be 3 units to the right and 2 units up. So from 0, 0, that's 3 to the right, 2 units up. We're going to go up 1, right 1. We'll also go from the vertex up 1, left 1. And then draw. These are called rays in geometry when you have an end point and continue on forever in one direction. Draw rays on either side of the vertex. The second example, because it's x plus 4 inside the absolute value, that's going to be left 4. And then we have minus 5 outside, so that's going to be down 5. So left 4, down 5. And we make that V that we've been making throughout this entire lesson. And there's our graph. And our last slide. Here we have words. So a vertical translation of 3 units down, a horizontal translation of 5 units right. So we have, I'm just going to say y this time equals the absolute value of x minus 5. It's the horizontal that's inside, minus 3 for the down 3. Graphing it, we are to the right 5 and we are down 3. We plot our points to create that V shape. Draw the rays through those points and you have your graph. And our last example, vertical translation of 2 units up, horizontal translation of 3 units to the left. So there's our vertex. And the directions did say identify, so I should be writing this. Vertex is going to be -3, +2. Our equation is going to be y equals absolute value of x plus 3 plus 2. We can finish our graph by plotting the points to create the V and draw the rays through those points. And this is how you graph absolute value functions, but also how we write absolute value functions.